In this lesson, we are going to be working on graphing polynomial functions, and we also will be talking about the end behavior of a function. Now, the end behavior is what happens at the ends of the graph. What we're going to be talking about is as our graph continues with our x going to infinity, we want to know what happens to the y value. One thing I would like to mention before we begin is the symbol for infinity, as maybe some of you have already remember it. Kind of looks like a sideways 8. And that's our symbol for infinity. And we're going to be talking about the behaviors as x approaches a positive infinity, which means going infinitely to the right. And we're going to also be talking about as our x approaches negative infinity, or as our graph goes to the left. So let's take a look at a couple of functions we've already discussed in the past. So we'll start with our function of a line. So the first function that we'll talk about is our line that has a positive slope, and this function is our parent function. Notice that it's passing through the origin and again is a positive 1 slope. So as our graph continues infinitely to the right, or as x goes to a positive infinity, we're going to notice also that our y value is going to a positive infinity, or up to the right. As our x goes to a negative infinity, going to the left, our y value, or f of x, is going to go down infinitely to the left. So it's going to a negative infinity. If we use our parent function, but now we are using a negative slope, but still passing through the origin and the graph of a line, as our x continues infinitely to the right, or approaches positive infinity, our y value, or f of x, is going to go infinitely down, or to negative infinity. And if we reverse that, as our x values are going to infinitely to the left, which is negative infinity, our y values are going to positive infinity. Next, we're going to review our quadratic function, which is looking like our parabola. Remember, our parent function, f of x equals x squared, where we have our y value and our x value, our vertex being at 0, 0. When we are approaching with our x value positive infinity, going infinitely to the right, notice that our y values are going up, as well as when our x values are going to infinity to the left, or negative infinity, our y values also are going up. So with our x squared, for both the x value going to positive and negative infinity, our y value, or f of x, is going to positive infinity. When our parabola flips over and is going down, which is negative x squared, and our vertex is at 0, 0, for both x approaching positive and negative infinity, this time our y value, or f of x, is approaching negative infinity. So now we'd like to talk about a cubic function, which we haven't done yet this year. So first thing we want to do is to make a graph of our cubic function, and then we want to talk about its end behavior. So to make the graph of a cubic function, we're simply going to make a table. We have our x and our f of x, and we're going to choose some points, and we'd like to pick values that are close to as possible to the origin to graph. So I'm going to pick some values for x. I'm going to start with -3, -2, -1, 0, 1, and 2. So what we're going to do is we're going to take the -3, and we can either use synthetic substitution, or we can simply do direct substitution and plug those in. And when I do that, my y value for -3 will be a -3. And when I plug the -2 into the equation for my x values, either by direct substitution or synthetic substitution, I will get the value of 5. For -1, I also get the value of 5. When I plug in 0, I have the value of 3. When I plug in a 1, I have the value of 5. And when I plug in a positive 2, either with direct substitution or with synthetic substitution, I have a value of 17. So I want to plot these 6 points onto my coordinate grid, and then I want to draw my cubic function. So when I plot these points, my first point, -3, was off the graph that I selected. Then I'm going to plot -2, 5, -1, 5, 0, 3, 1, 5, and then my 217 will be off the graph. So what we want to do then is to draw our cubic function and make it the curve as smooth as possible. So since I'm drawing freehand, I selected a graph that was pre-done for me. But notice when you have these 2 points, the -2, 5 and the -1, 5, if we were to have selected the point which would be at -1.5, we would have come up a little bit higher, so we need to get that curve in there and go below just a little bit after our 0, and then we're back up. It creates somewhat of an S when we're working on that value. So that is going to be the general shape or somewhat of what a cubic function looks like. So now we need to talk about the end behavior of a cubic function. Notice what happens on a cubic function where our leading coefficient is a positive number. When we are going with our x values to -infinity, our y values or f of x are also going down to -infinity. And when our x values are going infinitely to the right or positive infinity, our y values also are doing that as well. So in the next slide, I'd like to show you what the parent function looks like basically for a cubic function for having a positive leading coefficient of 1. This is what the function would look like. And as x again approaches positive infinity, so will the f of x. And again, as x approaches -infinity, so will the f of x approach -infinity. Then when we have our leading coefficient being -1, notice that we have the reverse happening. As x approaches -infinity, my y or f of x is going to approach positive infinity, and as my x values approach positive infinity, my y or f of x values are going to approach -infinity. Now I'd like to look at a function that is to the 4th power, which is a quartic function. So first thing we would like to do is to make a table and then graph some points, and then we're going to connect those points as smoothly as possible to make our function. So let's again start close to the origin, -1, 0, 1, 2. So when I plug -1 in either by direct substitution or by synthetic substitution, I will get a value of 5. When I plug 0 in, a value of 1. When I plug 1 in, a value of -1. And then unfortunately, when I plug a 2 in, I'm getting off of my chart. So now I'd like to graph these 4 points. So when we graph those points, you'll notice that the shape is similar to that of a parabola, and you're going to get kind of that shape, but then depending on the rest of the function, we'll have some strange dips and things happening, but it'll be similar to that of a parabolic function. So we want to take a look at the end behaviors of a quartic function. When we look at a quartic function that is the parent function, it's going to be very similar to that of a parabola. So with our leading coefficient being a positive 1, we know that both of our end behaviors for x, whether being going to positive or -infinity, the result for my f of x or y will be going to positive infinity. It behaves like an x squared function or parabola. Then with our -x to the 4th, again, it's just going to flip over our x-axis, and as x approaches both positive and negative infinity, our y value or f of x will approach -infinity. I do have some hints for you that could be helpful when you are talking about end behaviors. If the degree of the polynomial is even, which means it's an x squared, an x to the 4th, x to the 6th, x to the 8th, if your leading coefficient is greater than 0, meaning that it's positive, For both the x values going to positive or negative infinity, your graph will be going up for the y value or f of x going to positive infinity. And if your leading coefficient is less than 0, meaning it is a negative number, your graph will flip over the x-axis, and both the x going to positive and negative infinity, the f of x will be going to negative infinity. Then, if your degree is odd, so you're going to the first power, the third power, the fifth power, if your leading coefficient is positive, your x going to positive infinity, so will your y value or your f of x. If your x is going to negative infinity, so will your f of x value. If your leading coefficient is less than 0, then, which means negative, if your x is going to positive infinity, then your y will be going to negative infinity. If your x is going to negative infinity, then your y will be doing the opposite and going to positive infinity. So let's take a look at some examples of functions, and we want to be able to look at what their degree of that function is and then be able to tell what the end behavior is doing. In our first example, you'll notice that our function is not in standard form, so we need to write that in standard form, negative 2x cubed plus 3x squared plus 4x. So we take a look at our degree of our polynomial and its leading coefficient. It is to the third degree, so that one is going to be an odd degree, and the leading coefficient is negative. So what's going to happen as x approaches positive infinity going to the right, we know that then f of x is going to approach negative infinity. And as x approaches negative infinity, f of x is going to approach positive infinity. Remember, this is a cubic function, and we have our negative leading coefficient. So the general shape of that is the one that looked kind of like this. So you can see that happening. In our next example, we will go over here to the right. We are going to see that again, we're not in standard form, so we'll put our function into standard form. The degree of our polynomial is to the fifth degree, and our leading coefficient is positive. So this time, our function is going to look something like this. And so, when we are looking at our end behaviors, as x approaches positive infinity, we'll notice that f of x is going also to a positive infinity. And as x approaches negative infinity, you will notice that our f of x also approaches negative infinity. Let's take a look at the next example, and this example happens to already be in standard form, so we're going to take a look at our largest degree, which is to the fourth, and our leading coefficient is negative. So that's going to look similar to our parabola that's flipped over the x-axis. So as our x value approaches positive infinity, our f of x or our y value is going to approach negative infinity. And then as our x value approaches negative infinity, we also notice that our f of x is going to approach negative infinity. Let's take a look at the last example. Again, this one is already in standard form, so we're going to find the largest degree. It is to the second degree, which is even, and the leading coefficient is positive. So we do know that this is a parabola and it is opening up. So, taking a look at our end behavior, as x approaches positive infinity, we notice that our f of x also approaches positive infinity. And as our x approaches negative infinity, our f of x value also is going to approach positive infinity. Whoop, that should be positive infinity. So let's review. When we are working with polynomial functions, we are going to determine, after our function is in standard form, what the degree of the function is and what the leading coefficient is. Then we can determine what the general shape of that function would look like to find out what the end behavior is going to do. So when you are graphing a polynomial function, be sure to determine the end value. End behavior, make a table of values, plot the points and make as smooth of a curve as possible, and then check that your end behavior is in the right place.